So, first of all, welcome to Florence. It's absolutely beautiful. Like it's nothing I have ever seen before. And after coming here, I realized that it's such a beautiful city. Everything's so pretty. Maybe it's probably not the best time to talk about grotesque stuff like dead code, scavenging, vultures. So I got an idea instead. How about we talk about football? We're in Italy, come on. So, yeah, I think all of us played football at some point in our life. And if you were like me and did not want to play it, your school probably shoved you or your parents probably asked you to. It's because football isn't just about kicking the ball. It's a lot about indirect learnings. When a kid plays football, they also learn virtues like sportsmanship, how to work with a team, leadership, etc., which are much, much more important than having a perfect three-point stance, which isn't bad either. So, and these kind of indirect learnings, I like to call them head fakes. And for people who are not familiar with the terminology, a head fake is when a player does a stance where they want to kick the ball in some direction, but they actually kick it in some other direction. And actually, an Italian player, Vulture, I'm sure everybody would have heard of him, was the master of this stance. Here's actually a video of him scoring. Look at it. It's absolutely beautiful. I'll play it once more. Oops. Here it comes. There. So, yeah, I really like it. And these are the kind of head fakes which are there everywhere in life, and you should watch out for them. And I know what you're thinking. We're Italians, we know our football, we don't want anyone outside coming us and telling us how to play football. So I think it's best we probably switch to code quality back. So yeah, so before going in, I just kind of wanted to get a little bit like warming up by talking about why should we care about code quality. I mean, like, why do you think? Anyone from the audience? Quickly in 3, 2, 1, someone. Okay, I'll start. So, so I think there are some obvious answers to this. First one is that it prevents bugs, and thusly it prevents downtimes, and that's a good thing, right? And it also prevents you from accumulating more technical debt. Like all debt, it needs to be paid in the future, and it will keep accumulating, keep compounding. And compound interest can work very well and against you and for you. So you want it working for you and not against you. It also makes code much more readable, which again loops us back to point number 1, preventing bugs and downtimes. And I know this is all very important, and this should absolutely sell you to to care about code quality from the very start and to maintain good code health. But really, if they ask the question, why should we care about code quality? And I think the answer to that is because it makes us happy. If we write good code, we'd probably go and want to post it on Twitter, on Reddit, on Hacker News, and want to talk to other people in conferences like this if we build something good, and not wish that our boss just doesn't see it and it slides away. So it makes us really happy and want to continue keep working on the product. So that is my answer to why I care about code quality in general, so that I can be proud of my work. Now with that out of the way, a little bit of introduction. Hi, my name is Rahul Jha. I'm from India, Bangalore, and I work at this startup called DeepSource, which is a single platform for managing code health and code quality. And they were generous enough to sponsor my trip to Italy, and I just wanted to give a huge shout out to them. And yeah, and this is the website where I blog. You can check that out. So this talk, it is about this tool called Vulture, which can be used to detect unused Python code. And Before that, like you'd probably be wondering, why do we need to why is there unused code at all? I think it's mostly because when you're refactoring some things or you're renaming stuff, you probably like forget some things, and if you're debugging, you maybe assigned a variable to a value and you forgot to remove it. Has happened with me quite a while. Or it could be a programming error, or it could just be a misspelling, and then you went ahead and defined your own function if you didn't find one. So all of these are the main causes why you end up with unused code in your program. And why it's bad? It's bad because, first of all, it slows your execution time. Also, it increases your program size, and it might introduce unintended bugs, which is to say, for example, if you have an unused import, it can hijack your global state and pollute it. It can also, again, unused imports are the #1 thing I go look for when I'm speeding something up. I go look, I don't need it. That's the fastest way to win. It's also maintenance overhead. If someone new joins the team, they're probably wondering what this piece of code is doing here, just sitting, doing nothing. So there's quite a few reasons to that, why you want to remove that code from your project. And here is where Vulture comes in. It's a simple executable. You just pip install it, give it the file path, and that should be working. I can give you a quick demo here if everything goes well. Wish me luck. Oops. Yeah. So I can just go to pip install Vulture, and the Wi-Fi obviously won't work, so I have got a backup. So this here Vulture is already installed, so we can do something like vulture --version, and oops, yeah, here we go. So what I have here is I've got this file, like simple script, and what I want to do is just to run Vulture over it. I just do demo1.py, and that's about it. That's like the 80% of the stuff that we are going to cover. The rest 20% is the deep dive into some of the technicals and some other stuff. So it's the usual format, the line number, you get the file name, kind of information. You'd also notice that there is this confidence value, which we'd come on to later. But for now, I think this is just the absolute basic minimum you need to get started and get Vulture running on your project. What is the next thing? So in my experience, when you have a mature enough project, a big enough project, and you run Vulture on it, there are two problems which happen. Let's start with the first. There are quite a few false positives. And what can you do with what are false positives? Let's take a look again. Sorry, yeah. So I'll show you another piece of code. So I hope this is readable at the back. It is? Yes. So this is just a simple function. What it does is it's print chow. Let's try and execute it. Yeah. And if I run Vulture over it, it's fine. It works. But let's try and do some modifications to this program. Rather than calling the function here, greeter.greet, let's do something more like, we have a method caller. It is if you want to programmatically call your function instead of directly calling it. And then if you do any of this fancy stuff, and let's try running Vulture on it once again. So now it says that your method is unused. If you go take a look. So the reason why this happens is, we'll go into this later, but these are the kinds of false positives due to Python's dynamic nature. We cannot link everything back to its original source, and that is what messes it up. So how do we deal with it? I mean, any guesses? Yeah, please go ahead. Oh yes, we could. Yeah, that's a good idea. So actually, like, this brings me to this. So if I use my unused code, it isn't unused no longer, right? So And that I'm actually not totally kidding here. So I'll show you something. So what we can do, as gentleman said here, that we can create a whitelist. And this whitelist is just a usual Python file. It is not something that, it's not something specific to Vulture, but it is like kind of the way we support tracking false positives. So I can go and I can do something like, okay, chow, just this, just the name of the function. I don't even need to specify where it came from, and it should work fine. Demo3.py, and if I go with, it works. The way it works, we'll come on to that later, but one thing that can happen is if you go and rename this file, if you, let's say, do greet here, and I think you need to do greet here, it would come back again. So how do we track that we don't have any stale data into our whitelists? So one way of doing that is, rather than just having whitelist like a plain only functions, we can actually import stuff, the actual stuff, and this won't make your application any slower because you're not running this whitelist file. It just stays there, and it doesn't need to be in the root file. It can be there somewhere in some obscure corner of your repository, and it should still work. From demo3 import greeter, and we just need greeter.greet, and that should work. And if I go ahead and change it again, let's say I went with chow again. So even though this would fail, how would you detect this is you can just keep running whitelist file with your Python in your CI/CD pipelines, and it would fail as soon as you have a stale value over there. So that is something that a lot of projects I've seen doing, and I absolutely recommend. So yeah, so that was one way of dealing with false positives. Quite a few other options as well. So you can ignore certain files, like auto-generated files, like migrations. If you're using something like Django or Flask or Alembic, you would have automatically generated files. There's a zero probability of finding any interesting results over there, and you don't control it, so you can just ignore them. You can ignore patterns like this. If this is very useful if you have like a Flask project, so you can ignore decorators, abroot root. So what this would mean is any function which is decorated by this decorated would not be reported. And you can, if you have a visitor pattern class, for example, you can just ignore all the functions which start with visit underscore, and they would be. So any piece of code which you know has a pattern and is implicitly called, you can just ignore them. The other thing you can do is mark unused variables by starting them with an underscore. It's a standard with Python, and Vulture also respects it. And last but not the least thing is particularly useful when you have a lot of results. And again, we'll come about this in the later part of the talk, where we deal with how do we deal with so many results. So if you have, so you can specify a minimum confidence value to the results. And what Vulture does, it has a rough approximation on what types of results can it detect with absolute guarantee that these are unused. Some of, like imports, for example, unused imports can be detected with like an accuracy of 95% roughly. But unused variable names are very, very common to having false positives. So you can have something like the number 80 is good if you want to have like only good enough results. The other problem that I mentioned with running Vulture is that it can be overwhelming. You can see maybe 1,000 results, and what do you do in such a case? And the prioritization matrix basically says optimize for something which is easy and also has the maximum output. So in that case, Vulture also supports a command line argument called sort by size, -- sort by size, which you can give, and that would mean that all the large parts of your code base. So for example, if I go back here, so this is the I just found it on GitHub trending last night. This was the #1 trending project for this month, and I went and run Vulture on it, and I see quite a few results. How do I do, like, these are 150 results. How do I prioritize this? So you can do something like sort by size, and yep. So you already have got 251 lines result here. And yeah, that's some improvement. Let's go back to slides. So the next question is, I'm sold. How do I run this in my CI pipeline? So you can either run the CLI, you can also run it as a pre-commit hook, and you can also run it as a part of your test suite. One interesting thing is if you run Vulture both on your code and on your test suite, you can also find code which is not tested. So that is another good thing of having it running in your CI pipelines. It also has a Python API, which you can use if you want further customization. Now, I think we have some time on us. Do we have some time? Yeah. So 5 minutes. Yeah, that's good enough. So I mentioned that we'd come on to like having false positive. Like, why does that happen? I just want to dive in a bit more deeper. So first, let's walk into how Vulture detects unused code. And to go with that, I think first we need to understand, so Vulture works on something known as an abstract syntax trees. How many people, just as a show of hands, who know about abstract syntax trees or ASTs? That's quite a few. I'll just give like a very brief walkthrough. So what a tree representation of a code is, it's abstract, it's not concrete, it does not deal with line numbers, column numbers, or the syntax. It only, if you have a perfect, if you have some code which adheres to the Python's grammar and it can be parsed, then you can create a syntax tree out of it. And before going to like code syntax trees, let's look at like mathematical expressions. So for example, this one, how would you evaluate it? We know in India we have this mnemonic called BODMAS. First you operate on parenthesis and then you go on and on. So for example, I know that I need to multiply first, so I have my tree something like this. And then we'll do a post-order traversal, which is basically starting from the bottom and coming towards up. And we got 2 and 3 multiplied 6, and this way we can just arrive on a final number. And let's go on to some code next. So if we were to have a syntax tree for a simple if-else condition like this, we'd probably go for this. So this is not concrete. It does not tell me which line number comes first or what. It is just an abstract representation of how my code looks like. If you do this comparison, and we'll have some metadata like this is a variable, this is an integer, this is a string, and stuff like that. So we can walk through one more example if you want. This is a function representation, a function definition, and we'll have a function definition node for this, and it will have some things like name, how many arguments it has, what the body of the function looks like. Let's go for like a more complex one. So yeah, this one. So first we have an assignment. The second we have a function over here. And the third we have is a comparison. If .name equal to .main, we have the comparison. So I just color coded it so that it is visible. And the way we would have is, consider that we have 2 buckets. One is used buckets. One is the bucket which we'll store defined values, and one is where we'll store used values. And what we want to do next is we want to go step by step into this AST, into the syntax tree, and just see what all kind of statements are there which can produce values. For example, an assignment would create a variable. So as soon as we go to traverse the assigned node, we go and put it into our defined bucket. Similarly, a function definition node will also produce a value. So we go ahead and we pull in the name of the function and the name of the arguments. These are another two variables which are introduced. Similarly, we'll go for traverse the if condition, but we don't have any new variable. And we'll do another pass now. We'll go and we'll try to parse what all values are being used or being loaded into our system now. So assignment does not load any value. It does not look up, at least not here. And similarly, our function definition, it does not, it does read one value. It reads the last name argument. You can see it here. It reads the last name argument. So we go and put that into our used bucket. Similarly, we go loop through the if one, and we got the person variable in the use bucket. Now what we need to do next is we just need to subtract this, get the result, and we get the unused object. And we also have all the metadata information on these nodes, so we can get the line number, the file name, etc. here. Now all of this is fine. You want to see, okay, show me some code. This is all just diagrams. So what Python's AST library, and pretty much for every other language also you get, is that you get like a standard library which you can use to additionally get. So the standard library would do all the traversal of the trees and essentially give you hooks into that process. So whenever you encounter a function definition node, you can just hook in your own function, and then you can do whatever you want with that. So for example, if I have some example code over here, and I run just these 3 lines of code, what it'll do is it'll produce this output on the top right. So it's pretty easy to do this in Python. And so the next time you want something, like for example, if you have a convention where you want to have functions which only start with, say, letter A or letter wizard, and you want to write a test, this is probably the right way to do that. And yeah, and also since like the matter of false positives, why those false positives happen is that somewhere the link in this AST breaks. For example, it would be a string here rather than a variable load in the print statement, and that would break this algorithm. That is why we have false positives. And I think we are running out of time, but I'm almost done. I just need to give this final thanks, vote of thanks. Generic Sipe, he is the original author of Vulture. Me and him, we co-maintain it. Florian is actually in the room, and he rented me this equipment. Thank you so much. And thank you. Thank you.
Thank you, Rahul.
Yeah, just one line. So we talked about head fakes, right? Did you figure out what the head fake with this talk was? It wasn't to give you a brief overview of how Vulture works or how anything of this works. It was to kind of inculcate this value of like, we need to care about code quality more, and if we do, like, how do we go about doing it? How can we write more tests which ascertain certain parts of code quality? And that's it. I won't take any much of your time. Thank you so much. Thank you.
Okay, we have 2 questions, Rahul.
Yes.
The first one, what about running Vulture as a PyTest or some other testing suite plugin in order to deal with false positive without whitelisting so that you can exclude code that did not run during execution?
So you can, I did not get the question. Can you repeat the last part?
So you can exclude code that did run during the execution using Vulture as a PyTest plugin.
I think both of them are quite different. You can actually make a plugin with PyTest, but since Vulture is like a nicely behaving Unix tool, CLI, if it fails with a nice exit code. So I think you can just go do that, but it is entirely possible to create a PyTest plugin which will do that for you. I'm not sure about the part where, about the unexecute. Yeah, go ahead.
I guess in big code base, if your legacy code that you want to drop is tested, you will get a fake negative because your code is tested and actually called by PyTest.
Yeah. So you can rely on that, yes.
Okay, next question. What if I have an unused but tested code? Can I tell Vulture to ignore such code?
So the question, if I understand correctly, is if I don't have tests for it, can I still go ahead and run Vulture? Is that the question?
No. The question is, what if I have unused? Oh, sorry. Hi. Oh, wow. Yeah, the question is, what if I have unused code, but I have tests for it? So I wrote it in the past, I wrote tests for it, and I'm no longer using it. Can I tell Vulture to ignore it?
Excellent question. So what I will recommend in this case is you need to run Vulture twice. You need to run Vulture on just your code base, and then you should be running it on both your code base and your test suite so that you can get both of those cases sorted. That answers. Yeah.
Okay, last question on Slido, then the other question. In your experience, what are the most prevalent causes of unused code? Is it more by mistake or bad style?
I think it's mostly you're debugging something. For example, I ran this on CPython sometime before, and what I found was there was this condition called if false and something. And that was probably because they were trying to debug something and they didn't want the code execution to go there, but it stayed. And it had been in codebase for, I think, 15 years at this point. So yeah, it's mostly by mistakes, yes.
Okay, time for a live question.
Hi.
Hello.
Thank you for the talk. What is confidence?
Confidence, yeah, good question. So confidence is just kind of like a metric we came up with because we wanted people to have some sort of metric to prioritize the results and to also, so for example, it is associated with the type. For example, unused imports always have a 95%. Unused variables, whenever it is reported, they're always reported with 60%. And functions are reported with, I think, 75%. So it's mapped to a particular type. So that's it. It's just for people who don't want to see all of those results and only want to see like a particular category of results. Yeah.
Yeah, thanks for your talk. It was really good. Do you know if there is any integration with tools such as SonarQube or code quality analysis to keep track and eventually from a UI create your own whitelist and keep track of what you choose to ignore and have the KPI tied together with the coverage, code smell, stuff like that?
As a matter of fact, yes. So I work for the company called DeepSource, and they do exactly that. So you can just, and you don't even need to configure that. They have their own runtime. So what we can do is we can just give a simple .deepsource.toml file. We can say, I have Python code over here, and they'll run all kinds of analysis, security analysis, network analysis, and obviously static code analysis. And they also have a very nice UI. We can go and configure, ignore certain rules if we want to, and stuff like that. Yeah, I hope that answers your question. Thank you.
Thank you again, Rahul.
My pleasure.